Good afternoon. I'm Cheryl Warner in NASA's Office of Communications. Thank you for joining us today to discuss SpaceX's 9th Commercial Resupply Services mission to the International Space Station. A Dragon spacecraft is set to deliver nearly 5,000 pounds of science, crew supplies, and hardware to the orbiting laboratory. The spacecraft is scheduled to lift off on a SpaceX Falcon 9 rocket at 12:45 a.m. Eastern on Monday, July 18th from Space Launch Complex 40 at Cape Canaveral Air Force Station in Florida. Here to discuss the mission are Joel Montalbano, Deputy ISS Program Manager for Utilization, NASA's Johnson Space Center. Hans Koenigsmann, Vice President of Flight Reliability, SpaceX. Julie Robinson, Chief ISS Program Scientist, NASA's Johnson Space Center. Captain Laura Godoy, Launch Weather Officer, 45th Weather Squadron. And Cody Chambers, Range Safety, Kennedy Space Center. Each speaker will deliver brief remarks. Please hold your questions until the end. Anyone on the phone line can press *1 at any time to ask a question. To submit a question online, please use the hashtag AskNASA. Joel, we're excited about the cargo headed to the space station, especially the International Docking Adapter. What can you tell us about both?
So, first of all, good afternoon, and welcome back to Kennedy Space Center. It's great to be here for another commercial resupply service mission. We're looking forward to this mission. It's bringing critical supplies, critical hardware, like you mentioned, the International Docking Adapter to the International Space Station. We got a busy week ahead of us. So just later this afternoon, we'll have a progress launch from Baikonur, Kazakhstan. They're scheduled to launch at 5:40 Kennedy Space Center time. They'll go ahead and dock Monday evening around 8:30 Kennedy Space Center time. We'll have this launch just about 15 minutes prior to 1 a.m. Monday morning, and then the berthing on Wednesday morning, Kennedy Space Center time. So, and this just adds to the busy time we've been having. About a week and a half ago, we had a Soyuz launch from Baikonur, Kazakhstan. 3 new crew members were added to the International Space Station. The crew has wasted no time getting acclimated, and they're running and going. I mean, they are picking up the science program that we've been working so hard to maintain for everyone. They've just been picking up without a beat, so we're glad to see those guys are there. As far as this mission, again, another mission coming to the International Space Station. The commercial resupply services for both SpaceX and the orbital team have been just doing a fantastic job for us. So we're happy to be a big part of this mission, and we're looking forward to the launch. Thank you.
Thank you, Joel. And now we'll hear from Hans with an update from SpaceX.
Right, good afternoon. I'm excited to be here. This is our second Dragon mission for this year. And as always, I'd like to thank NASA for the opportunity to supply the space station. And in this case in particular, I also want to thank the FAA and the 45th Space Wing Safety Organization because we had a lot of work over the last couple of weeks to prepare for the land landing that we're going to perform this time. I'm just coming from the static fire. We static fired earlier today at I think it was 8:30. We had operations going through the night. Everything looks very good right now. We're gonna have a data review later today, and that's gonna be a launch readiness review at the same time. So I don't expect anything at this time other than a go for Sunday to Monday night. The launch time is 45 minutes after midnight, 45 minutes and 23 seconds, I think, currently. We have a backup opportunity on, I think it is Tuesday night to Wednesday on the 20th. And that actually currently is 17 seconds after midnight, so it might shift left or right a little bit and actually jump the day, which would be pretty funny. This one also is interesting for us because we have obviously Monday here in Florida and still Sunday back in California. So I will see this book kept under 2 different dates in the future here. So 7th mission for this year, basically, and we've been ramping up the missions over the last couple of months following our investigation. I'm also really excited about IDA and now how critical this is for NASA and the ISS in general. And also, of course, for SpaceX going forward with Crew Dragon. So this is a really important piece of hardware. It's an external piece of an external payload, which is in the trunk of Dragon and needs to be pulled out with the station robotic arm. So regarding landing, you will see the first stage burn for about 2 minutes and 20 seconds, 2.5 minutes roughly. And when it shuts down and deploys the second stage, you'll see probably, if the weather is good, of course. Actually, you don't see it because it's dark. But if it would be daylight, you would see the stage turning around and doing a boost back burn. That burn is pretty long. It's a 40-second, 50-second boost back burn on the first stage, followed by an entry burn about 6.5 minutes after liftoff, and then that is followed by a landing burn right around 8 minutes. The landing is going to occur at landing zone 1, which is the old Slick 13 or 12. I forgot exactly which one it is. I think it's 12. Down in the at south of the in Cape Canaveral, a couple miles away from the launch site. Second stage continues for another 6.5 minutes. It will deploy the nose cone after about 40 seconds to a minute. And then Dragon will be deployed about 30 seconds after shutdown and will be on its way to the station over the next couple, 2 days actually, and then be birthed by the robotic arm again. That's all I have right now. I'm really excited again and looking forward to this mission.
Thank you, Hans. We're really excited and looking forward to this mission as well. Now, Julie, what can you tell us about the trailblazing science that we're sending to the International Space Station?
Well, Dragon is a really important vehicle for science because of its capabilities in launching live samples and also for its return capability. So we have about 930 kilograms of research samples going up and about 580 kilograms of samples coming back home. One of the things that I really notice across all the cargo on this flight, and it's supporting literally hundreds of investigations that are going on the space station right now, one of the things I notice is a number of studies that are looking at genetic, gene expression, proteomics, and all of these molecular approaches to understanding life that are so important back here on Earth in personalized medicine. Those are also being studied in space, and it's interesting the kinds of samples that are included, things like heart cells, muscle cells, bone cells, a mouse study looking at epigenetics, which is being done for our Japanese colleagues, plant seedlings. All of those are going to be studied in terms of their gene expression and how being in space really affects those organisms. Also, there are really interesting applied physical sciences, such as studies of hard-to-wet surfaces being done by Eli Lilly, studies of copper, tin, and copper-silver alloys being done in collaboration with our European colleagues, studies of phase change heat exchangers and a new facility that will let us continue to do new studies of how to better do thermal control in space. And another interesting thing that's going up is an instrument to help in managing maritime traffic back here on Earth. We'll have a briefing tomorrow with some of these scientists to tell you about some of their work, but from an overall perspective, this is just part of the rich stream of research going on in the space station, from human research, biology, physical science investigations, and things for exploration technology. Thanks.
Thank you, Julie. It's pretty incredible what we're able to accomplish up there. Now, Laura, how is the weather looking for this launch?
It's looking pretty good, Cheryl. First, let's take a look at the satellite imagery. You can see the high-pressure center over the Atlantic Ocean has a ridge axis extending into central Florida. This ridge axis is causing southeasterly wind flow today and is expected to push north over northern Florida tomorrow, which will cause more easterly flow Sunday night into early next week. You can also see the sea breeze, the East Coast sea breeze progressing inland, as well as triggering afternoon thunderstorms. And with the onshore flow being stronger tomorrow, we're expecting those afternoon to evening thunderstorms to progress west of the spaceport. And on Sunday, over the mid and upper levels, we're expecting high pressure to build over the central United States. With the building high pressure center, we're expecting relatively light winds aloft out of the northeast. And again, with that northeasterly flow, it'll keep all convective activity well west of Florida's east coast. As we take a look at the launch forecast, you can see that we are going for just few to scattered skies and no significant restrictions to visibility. The winds will be light out of the southeast, and the winds will be off the ocean, which will cause the overnight temperatures to remain in the lower 80s. Because the launch time is just prior to 1 a.m., we're expecting the majority of the daytime and evening thunderstorms to have dissipated over central and western Florida. And the cumulus clouds and overnight showers that we typically see in the easterly flow regime will not really develop until after 4 a.m., extending into just prior to noon on Monday. Therefore, the probability of violation will be low at launch time at 10%, and this would just be due to the cumulus cloud rule and the Dragon capsule's flight through precipitation rule. Since the conditions are not changing for the first stage flyback and landing, we have no additional weather concerns regarding violations. In the event of a delay, so a launch Tuesday around midnight into Wednesday morning, we expect similar weather conditions as the first attempt. The only real change in the weather pattern is the potential for a tropical easterly wave to progress through the pattern. And these easterly waves may enhance the nocturnal cumulus clouds and showers, as well as increase the cloud coverage over the area. Therefore, the thick cloud rule has been added as a primary weather concern, and the probability of violation increases to 30% for Tuesday night. So overall, we expect just few to maybe scattered clouds for the launch time, with a full moon out as well. So if you're able to, I hope you're going to come out and watch the launch. That's all I got, Cheryl.
Thank you, Laura. And now we will hear from our final speaker, Cody, with an update on the range.
Thanks, Cheryl. Good afternoon, ladies and gentlemen. We're targeting launch of the 9th SpaceX commercial resupply mission for NASA to the International Space Station for 12:45 a.m. Eastern Daylight Time. That's local. In advance of the launch, the 45th Space Wing provided KSC with a risk analysis that was provided to us yesterday. We determined we are go for launch. There are a number of safety assessments performed by the wing and evaluated by NASA before each mission. NASA range safety engineers here at KSC accepted the current risk assessment, which required taking some mitigating actions for debris and toxic dispersion risks. These actions included clearing a number of NASA facilities here at KSC within the hazardous launch area. The Brevard County community outside of KSC was not affected, however. Any facility within the launch hazard area, this includes the press site, will be cleared at 60 minutes prior to the launch time. The dispersion risk for this launch is driven predominantly by the onshore winds present this time of year. The analysis is performed based on the forecasted weather data and will be refined as we move closer to the launch time. Following this assessment, we'll continue to work closely with the wing to refine and fully understand the toxic dispersion modeling present, and we'll work toward making sure everybody has an exciting and wonderful view of the skies tomorrow night. Cheryl?
Thank you, Cody. We'll now move into our question and answer session. We will begin with questions in the room, so if you have a question, please raise your hand. We will take questions after that from the phone line. Again, to enter the queue, please press *1 at any time. And to ask questions online, please use the hashtag #AskNASA. We'll begin with Bill in the back.
Hi, Bill Harwood with CBS News. For Cody, can you go into a little more detail about, this is obviously, I guess, for SpaceX Dragon abort scenarios and the toxics that are on board the Dragon capsule if there was an abort. Would you just talk about that and what could get released? Or maybe that's a Heinz question, I don't know, but just go through the analysis for me.
So
Thanks.
I can speak to the analysis provided to NASA by the 45th Space Wing. What we're looking at is, in the event of a Dragon abort scenario, the predominant winds would carry the spacecraft back toward KSC property. The spacecraft, on impacting the ground, could see a risk of releasing its toxic commodities. As such, we need to take actions to ensure that our people, the viewing public, as well as visiting guests are kept safe. So we thought it prudent to move visitors outside the areas of highest risk due to the winds. And I'm not sure if we could speak to the actual commodities on board of the SpaceX Dragon capsule, but.
That question, what are the commodities we're talking about? I mean, I think I know what they are, but I'd like for you to explain it. But I mean, what's going to be different on a manned or piloted version of the Dragon? Because obviously you're not going to have people on board if there's any chance of a risk of letting consumables like this get loose. So maybe the difference between cargo ship, manned ship in this context. Thanks.
So on Dragon, nothing is different from the last flight. I'd like to point that out. We we have hypergol propellants on board, and those are toxic. So I understand the precaution on the Ranger side. The wind is in an unfavorable direction, but on the Dragon side, nothing changed over the last couple of years in terms of design or anything in terms of risk to the public here, and from the design perspective. In terms of Crew Dragon, totally different situation. Crew Dragon has an integrated board system, so it's going to be, in case of any mishap, the capsule would basically save itself and the astronauts, and it would not get into the situation where you would impact the ground. Potentially, it would rather land safely on the ground after, pulling out and going to a safe distance. It's a very different situation to this Cargo Dragon. But I actually think all these precautions and risks are really, I really appreciate the range working with us in particular, not just on the Dragon side, but also on the landing side. We had a really fruitful cooperation with Range Safety, the 45th Space Wing here, to enable the landing and make sure that we do this in a safe way without any risk to the public.
Great. Next question from Irene.
Hi. Thank you. Irene Klotz with Reuters. Hans, just to be clear, the changes that were made to have to be able to recover Dragon in case of an accident, that would be for a parachute landing at sea. And this whole scenario driving the evacuation of the press site is in case that system didn't work and it landed on land?
No, I don't think these are related. I think what you're referring to is one of the changes we implemented after the mishap, where we could basically have saved Dragon by deploying the parachutes. And that's we've implemented that particular change from now on. But you need to get to a certain altitude in order to pull the parachutes out. And there's an initial phase early on where you might not be able to do this. So it's going to be enabled later on. I don't think it is related to that particular scenario.
Okay, thanks. And for Joel, does the Progress need to be docked before SpaceX is clear to launch?
No. So what we'll do is if Progress is going to launch and dock, and then SpaceX will loiter. If Progress had an issue, but right now Progress is Progress is going to be docked Monday night, and so there's no constraint to SpaceX launch due to Progress docking.
Thanks. And how long could SpaceX loiter?
I don't have. Do you have the number of days?
It's probably driven more by your payload than by our spacecraft. We could loiter for a couple of days, but I think there's a payload time limit on board.
Irene, we can follow up with you afterward. Great. Next question in the yellow, please.
Marcia Dunn, Associated Press for Hans. Oh. Hans here.
Yeah.
Here. Sorry. I'm wondering, do you have a target date yet for your first recycled rocket launch? And what are you doing to the booster to, if anything yet, to get it ready to fly? And if you could provide a little update, too, on the status of your Crew Dragon and how that's going and whether you think you can still make next year for a launch. Okay,
so first on the reflight of the recovered booster, that's going to be most likely in fall this year. We are prepping the booster again, and first of all, we got to wash them, right? They come back slightly blackened, and and we're going to go through a series of tests with the hardware on the booster itself to make sure everything's working, everything's is functioning. We also have a parallel test program running to make sure that the booster is qualified for multiple reflights. So that is something that we need to close out before we fly. And then, of course, we need to have a customer. We are in talks right now, but we haven't finalized those talks at this point in time. But my guess on this would be it's going to be in fall of this year. Second question was on Crew Dragon. I believe we are on track right now on the demo mission. At least I'm somewhat familiar with the first one. I'm not sure I'm too familiar on what comes after that. So from what I know on the first Dragon mission, we're doing a lot of work right now. Everything is going. A lot of resources are going into Dragon to push the crew vehicle and to make sure it's ready to go by mid next year.
Thank you. And it looks like we have a number of questions. If you can, please keep your question limit to one at this time. And I believe we're going to go to the phone line for a question. Go ahead with the phone line. All right, James Dean.
Oh, thanks. And yeah, I'm sorry, I've missed a couple of spots here, so forgive me if you've answered this already, but just trying to clarify again if the evacuation of certain parts of KSC is related at all to the booster return, or it's exclusively a Dragon risk that's been evaluated here?
I'm assuming that was directed to me. The return of the booster does not introduce any additional risks beyond that we normally see with a return mission to the landing site 1 with SpaceX. The evacuation and clearing of some of the viewing areas here at KSC is driven by, again, the Dragon abort scenario.
Okay, thank you so much. And Hans, could you just discuss your, I guess again, what you think are the chances of success of a booster landing this time around? And given that I guess land is considered a little more favorable than the drone ship, right? And now that you have a few under your belt, how are you feeling about this next opportunity?
Yeah, so I mean, the land landing is it doesn't move. It's one advantage, and it's actually it's significantly bigger. It's a pretty good sized landing pad compared to the drone ship, and it doesn't have structure left and right that you need to fit the vehicle in. So from that perspective, that's going to be easier. Getting back to land requires a little bit more propellant, or significantly more propellant rather. But at the end of the day, those trajectories are also easier or more benign in terms of heat load and deceleration. So from that perspective, I think it's going to be an easier trajectory than the last one. Obviously, these landings are secondary in nature and not the main mission. The main mission is to bring cargo to the space station. So I'm pretty optimistic at this point in time that we landed, but I would always knock on wood. Just by the nature of this maneuver, it's pretty challenging. Let's say it this way. And I also want to take the chance and go back on what I said earlier about Dragon. I actually don't know what particular abort scenario drove that analysis. I'm not familiar with the analysis. I just want to point that out. That is something that I haven't seen. I have seen some of the numbers, but the details behind those numbers I'm not familiar with.
Great, and we will now go back to the room to take questions. Right here.
Ken Kramer, Universe Today and Northeast Astronomy Forum. For Hans, I have a question about also the other recovered boosters, the ones to GTO. They landed a little bit hard, 2 of them, and I don't think you're going to be able to reuse them. And the last one didn't land successfully. What are you learning from these hard landings that you might be able to apply? You're going to be changing the structure or any work on the Falcon 9, and any change in the actual landing scenario, how you do the landing, what you've learned from these hard landings?
So there's certain there's no structural changes, first of all, and in general, I think the landing concept with the legs and the number of burns and the way we perform those seems to work okay. The key thing is to protect the engines and make sure that they start up well. And in particular, the hot trajectory, so to speak, or the one that come in after a really fast payload like the geotransfer payloads, basically, those engines need to be protected such that they start up in the proper way, and that is something that we learned. We learned a lot by, even on the missions when things go wrong, like on the landing rather. Everything goes well on the main mission, of course. That's actually something that always bugs me. We have successful deploy and everything's fine, and then the landing doesn't quite work, and the landing gets all the attention. Yeah, but even on those landings, we learn a lot, and we learned, particular on the last landing. We believe we found a way to operationally protect these engines and to make it safer for them to start up and to come up to full thrust and stay at full thrust. So all in all, this series of drone ship landings has been extremely successful, even when we didn't recover all the first stages. Actually, we did recover them all.
You mean protecting the engines in flight? Is that what you're talking about?
Protecting the engines during re-entry.
Yeah.
That's when it gets hot, and we re-enter with the engines facing the flow. So it's basically the engine directly exposed to the hot flow, and that's when you need to protect the engines and the gases and liquids that are in the engine, make sure that nothing boils off and does funny things.
Next question, behind.
Lauren Gresh with The Verge. Hans, another question for you. But I know that if you land this one, your hangar is going to be a little full at 39A, so I'm curious to know about your storage options moving forward.
It's a good problem to have, right? I think we're looking at different places to store, and we need to actually. You got a good point. We are working on getting the hangar clear, and we have to start working on Falcon Heavy to get it integrated there. So I don't know exactly what our options are. I know that the team is working on that, and I believe we are looking at different hangars in the vicinity here.
Great. Next question from the room, right back here.
Hi, Jeff Faust of Space News. For Cody, was the timing of the risk assessment driven by the weather forecast because of the winds issue? And has there been, are you aware of previous cases of launches where you've had to evacuate KSC facilities like the press site and the VAB because of an issue like this?
Well, so the second question first, yes, absolutely. There have been several occasions in the past where we've had to move people for one reason or another, be it toxics, distant focused overpressure, or debris. To address your first question, we are driven by uncertainty. And the further out we predict, the more uncertainty there is in the model. So as we get closer and closer to the launch time, we'll get updated analyses run by the wing. Those analyses will then be passed to us in range safety here at KSC, and then we'll evaluate those and make adjustments as necessary.
Next question from the room.
Hi, so given the loss of the docking adapter last year, if there is any sort of catastrophic failure in IDA 2 or 3, is there any sort of contingency plan given that it's likely the Crew Dragon and Boeing Starliner will overlap in their times at the station?
So I'll answer that. Well, first of all, we have 100% confidence in SpaceX. We're going to get this guy up there and attach the space station as planned. We do have an IDA 3. That's in work as a result. You know, the loss, the first one, we've had this in work. We got planned that'll fly on a future SpaceX. I believe we're targeting SpaceX 14 for that. As far as docking mechanisms, we'll just manage what we have. There's not a constraint. We're going to be ready when the commercial crew program's ready to dock, and we'll just manage accordingly. Sure.
We'll stay with questions in the room, but please remember to identify yourself and who your question is directed to. In the very back.
Stuart Money, interspace.net, and my question is for Hans. Could you characterize how difficult this particular land landing is compared to the Orbcomm 2 landing? And what's the availability of propellant margin? Are you confident that the propellant is going to be there?
Yeah, it's a good point. The Orbcomm 2 landing or Flight 21 was very similar, actually. And I believe it is on par. I think we added some improvements over time, as I mentioned earlier, to make the vehicle more resistant against the recovery. So overall, I think it should have higher chances than that particular land landing, but it's going to be very similar. It's also at night, so you're going to see the same thing that you saw last time. Yeah.
For our next question, we'll go to social media.
And this is for Hans. John Kraus asks, how long approximately will each entry burn for each stage?
I think the entry burns are about 15 to 20 seconds.
Okay.
Why each stage? It's only one stage that comes back.
I'm just reading the question. And secondly, Escape Velocity asks, which experiments going up on SpaceX CRS-9 might help contribute to the commercialization of low Earth orbit?
Sure, that's a great question. There are a number of the experiments that are quite applicable to commercialization of low Earth orbit. Certainly, the Global Automatic Identification System, the global AIS, which is an application for commercial maritime traffic. That's a space-based capability that's important over the long term. This is a one-year test to demonstrate that capability. The work that Eli Lilly is doing, the work on the metal alloys, all of those different kinds of research linked to different industrial applications back here on Earth.
Thank you. I think we'll take a question from the phone line. Mark Gotch, please.
Mark Gotch, Historical Aerospace News. Good afternoon, a very informative briefing. I wanted to direct this to Julie. First off to say, Julie, the science payload going on board is going to be just incredible. Once again, going to the greatest laboratory ever created by mankind. And Hans, can you tell me, involving the actual Merlin engines, is there any change to those Merlin engines on this mission? And once again, the 45th Space Wing overseeing this mission as they did previously when SpaceX landed on land last December in 2015. They're erring on the side of safety and making sure that everything will be safe, and I commend them, and a good thing they're there. The truth is, can you tell me also, Hans, the dock adapter ring, what would be its exact weight as a payload on this mission? Thank you.
You want to start that?
Well, I certainly agree on the science. And I think there was a question on the IDA, how much that weighed.
About 500 kilograms.
Yeah. I got the question on the M1D. There's no change on that. So.
All right, we'll take our next question from the room,
I
please.
think we got them all.
Up front, please.
Hi, Thaddeus Cesare with the Utica Phoenix. I was hoping to hear a little bit about the IDA-2 and why it's critical to the commercial crew program. And then on top of that, what kind of impact will the commercial crew program have on the United States aerospace program?
So a couple things. The commercial crew program, they're going to be docking missions. And right now, the ports that we have on board the International Space Station are berthing missions. So the SpaceX and the orbital missions are berthing the ISS. So these docking ports will enable the commercial crew and enable those missions and those teams, the SpaceX team and the Boeing team. And I'm sorry, your second question?
What kind of impact will the
commercial
crew
impact of the
program,
commercial crew. Well, we're moving from, right now, as most of you are well aware, we're launching astronauts from the Soyuz vehicles outside of from Baikonur, Kazakhstan. With this move to the commercial crew, we're going to do a couple things. We're going to increase the number of USOS crew members to 4. And that 4th crew member, all his time is going to be dedicated to research and utilization on board. So right now, We tell the teams we average about 35 hours of crew-tended utilization and research. That's above and beyond all the autonomous research that's going on. We're going to double that from 35 to almost 70 crew hours once we get the commercial crew program. So that's going to enable us, enabling the partners and bringing that capability back to the United States is a huge benefit, and that'll be seen throughout the aerospace industry.
Can we expect to see some of the customers that would usually take a ride on the Soyuz migrating to the U.S. commercial crew program?
So right now we're planning to fly professional astronauts on board.
And will that be U.S. based specifically or international astronauts?
So it'll be international. So will be part of our partnership with the Canadian Space Agency, the European Space Agency, and the Japanese Space Agency.
And we have time for one final question right here.
Hi, Josh Jenner with the Orbital.Space. This question's for Hans. Has a booster been chosen specifically for the first reflight test, or has that decision been made yet?
The answer is yes.
Which one?
Okay. It's the CRS-8 booster. The last CRS flight. I think it landed on the drone
and
ship.
that was the first one that landed on the barge?
Yes.
Thank you.
Great. Thank you. That will conclude our briefing today. Our next pre-launch briefing will take a deep dive into the science headed to the International Space Station. So please tune in to NASA Television to hear more from Julie and others at 3 p.m. Eastern on Sunday, July 17th. As a reminder, we are targeting launch of SpaceX CRS-9 no earlier than 12:45 a.m. on Monday, July 18th. NASA Television coverage of launch will begin at 11:30 p.m. on Sunday, July 17th. Until then, thank you.